Welcome to tonight's video on the quotient rule. The quotient rule is when you have a product of the quotient of two functions when you're dividing two functions. And to find the derivative, you would take the denominator function times the derivative of the numerator minus the numerator function times the derivative of the denominator all over the denominator squared. That is the quotient rule. In words, this says that the derivative of a quotient of functions is the denominator function times the derivative of the numerator minus the numerator function times the derivative of the denominator all over the square of the denominator. And that is the quotient rule that is right here. So let's do some examples here. So first of all, we have x squared over sine x. And so that means that the numerator function is x squared. The denominator function is sine x. So that means the derivative of this is 2x. The derivative here is cosine x. So when we apply the quotient rule, we get 2x times sine x, that's f prime g, minus g prime f, so it's x squared cosine x, all over the square of the denominator, which is sine squared. That is your derivative. Now for part B, you have the derivative, the numerator is t minus 1. The derivative of that is 1. The denominator is t to the third plus 2t squared minus 5t plus 7. The derivative of that is 3t squared plus 4t minus 5. So now applying the quotient rule, this should be a t, these should be t's. There's no x's involved. So applying the quotient rule, you have t to the third plus 2t squared minus 5t plus 7 times 1 minus, and then fg prime, so that's t minus 1 times 3t squared plus 4t minus 5 all over the denominator squared, which is t to the third plus 2t squared minus 5t plus 7 all squared. So we can simplify the numerator here. So when we multiply something by 1, it's just itself. Minus, now here when we multiply, we get t times 3t squared, so 3t to the third, plus 4t squared minus 5t. That's what multiplying by t gets. Multiplying by negative 1 gets negative 3t squared minus 4t plus 5 all over t to the third plus 2t squared minus 5t plus 7 squared. So now you combine like terms first before we can combine the two sides. So when you combine like terms here, you get 3t to the third plus t squared minus 9t plus 5. So then you can subtract and you get t to the third minus 3t to the third, that's negative 2t to the third. It's 2t squared plus, minus t squared gives you plus t squared. Negative 5 minus negative 9 is positive 4t. And 7 minus 5 is positive 2. And then it's t to the third plus 2t squared minus 5t plus 7 squared. So that is your derivative. All right. So for part C, if you notice here, the top function, we'll call it f of x. The numerator, x cosine x, that has a product rule within itself. So we have, we'll call it w of x equals x. So w prime equals 1. And then z of x equals cosine x. So z prime equals negative sine x. So when you do the product rule to get the derivative of the top, you get negative x sine x plus cosine x. Then the denominator is x squared plus 1. The numerator, I'm going to use a different letter than f. Since f is right there, let's use h. And we'll use h here. So g of x is x squared plus 1. G prime is 2x. So we have, when we find the derivative of this, we take g times f prime, which is x squared plus 1, times negative x sine x plus cosine x, minus, and then we go hg prime, so we go 2x times x cosine x, and that's all over x squared plus 1 squared. So now we can simplify the numerator. When we FOIL here, we get negative x to the third sine x, and then x squared cosine x, and then minus x sine x, and then plus cosine x, minus 2x squared cosine x, all over x squared plus 1 squared. So notice we do have one like term that we can simplify. We have the x squared cosine x and the 2x squared cosine x. We can make that into negative x squared cosine x. Otherwise, we can't combine any of the other ones. So we just leave them all over x squared plus 1 squared. And that is your derivative for that one. But that was an example where you had to use the product rule and the quotient rule. So we'll skip the proof of the quotient rule. We'll go to how does the quotient rule help us? Well, we can use it to find derivatives of certain trig functions. functions that are quotients themselves, like for example, tangent is sine x over cosine x, right? So basically that means the numerator is sine x, the denominator is cosine x, so that means that the derivative of sine is cosine x, the derivative of cosine is negative sine. So when we take the derivative here, we get sine x times negative, we get cosine x, right, because we go denominator times derivative of numerator times cosine x, minus sine x times negative sine x, all over the cosine x squared. Well, cosine times cosine is cosine squared. Negative sine times sine is sine squared, but then you have negative and then negative there, so it's positive. And cosine squared plus sine squared is 1. And 1 over cosine squared is the secant squared. So that means the derivative of the tangent is the secant squared. And that's a rule that we're going to use moving forward. All right, for this one, let's change this to a sine t. So the derivative here, remember first, we need to change this to fractional exponent. So it's t to the 1/4 plus 6 sine t. Then when you take the derivative, you get 1/4 t to the negative 3/4 plus 6 cosine t. And then that's equal to 1 over 4t to the 3/4 plus 6 cosine t, and that is the derivative. So here, the numerator, well, first let's distribute the 5. So we get 15x squared plus 35x. And then here it's 6x to the 1/3. Now, instead of doing the quotient rule, let's split this up into two fractions. If you only have a single term denominator, you can split it up into two fractions. With the same denominator. And let's simplify them. So 15 over 6 is 5 over 2. 2 minus 1/3 is 5/3 with the exponent. 35 over 6 does not simplify, but 1 minus 1/3 is 2/3. So then when you take the derivative, you get 25 6x. 5/3 minus 1 is 2/3. And then here, when you multiply, 2 goes into 6 3 times, so you have 35 over 9. X 2/3 minus 1 is negative 1/3. So then it becomes 25 6 x to the 2/3 plus 35 over 9 x to the 1/3. Final answer. All right, let's look at the next one. This one you actually have to do the quotient rule because it's not a single term denominator. So the numerator is 3x minus 2. The denominator is x squared minus 1. The derivative of the numerator is 3. The derivative of the denominator is 2x. So when you do the quotient rule, you're going to have x squared minus 1 times 3 minus 3x minus 2 times 2x all over the numerator squared, which is x squared minus 1 squared. So when you distribute, you get 3x squared minus 3. And here you get minus 6x squared plus 4x, because you're going to distribute the minus with the 2x, all over x squared minus 1 squared. So then when you combine like terms, you get negative 3x squared plus 4x minus 3 all over x squared minus 1 squared. And that is your derivative. That is f prime of x. All right, that concludes our video for this evening. If you have any questions, please feel free to ask. Have a good evening.